Hi there. Today I'm looking at forced convection to heat a room. In other words, I've got a radiator in a bedroom that won't get the room up to the 21 degrees I want it to. Can't turn up the radiator anymore, can't turn up the heat anymore. Could put in a bigger radiator, but that'd be a lot of hassle and aggro. So the idea is to use forced convection in other words, blow air over it. To do that then, I'm using 3 of these. This is a 12 volt fan taken from a power supply, a computer power supply, used for cooling it. And as usual, I've got a lot of those because I don't throw anything away or try not to. So I've got 3 of those put together at the back here, connected. Just simply used what I call not Meccano, a cheap copy of Meccano, bolted the 3 together, stuck a couple of rods at each end. These are old furniture bolts. Could use anything, of course. It could be a lump of wood, just join them together with wood. Put them onto a little circuit board, so instead of soldering them all together, just plug them in, so if one goes down, I can just unplug it and plug in another one. None have gone down yet, they seem to be okay. Could just put these underneath the radiator, that's the idea behind it. Just put them underneath the radiator, there's the radiator, there's the 3 fans, and they then will blow the air up over the radiator, hopefully taking more heat from the radiator. But of course, if they're taking more heat from it, the air going through won't get as hot as it would by natural convection. So the air's not going to be in contact with the radiator as long as the natural convection, but a lot more will be going through. So although the temperature's reduced, the volume of air means more heat is coming out. And that's the principle as I see it. I could just switch these on and off as required, but I'd forget, leave them on all night and forget to switch them on in the morning. So I'd like some type of controller. You can go out on the internet and buy things like this, which is very nice. Has 2 displays. I believe one display shows us the temperature of the sensor which comes with it, the sort of thermistor type gizmo, very nicely packaged, and that would go on to the radiator. We can then use the setup button and the 2 arrows to set the temperature we want the gizmo to switch on at, and this other temperature would show us the actual temperature of the thermistor, whatever it is. Anyway, that's nice. I bought that just to play with, thought it was interesting. About a £5, I think it was, on the internet. That was after I bought these. I bought 3 of these, which I thought would be quite good. These then have a 12 volt in and a ground, and then 2 contacts that go to the relay. So if we wanted, we could use any voltage on these, not the 12 volts that's coming in to operate it. The interesting thing is about this, it has a 3 volt 3 regulator on the side there. So the board itself works on 3 volts 3, and it has a little, what I assume is a microcontroller here, so that these buttons can set up exactly what we want to do. Unfortunately, I bought 3 of these. I modified one and had tried to get it to work and found it wouldn't work. I then looked at another one before I'd done anything to it at all, and started working through to try and find why it wouldn't work. Took off the regulator over here and found there was a short between the output of that and ground. Went through the whole thing and eventually lifted up the edge of the chip here the processor chip, whatever it is. I don't know if it means anything. It's upside down. What is it? Can we see? Can't really see it. But anyway, I lifted up all the pins at this side so they're not connected to anything, put my meter on and found that the chip itself was short-circuited on the inside. So these boards then, bit of a waste of money. And as I say, 2 of them had gone down. So I tried the third, seemed to be alright, no problems there. So I went out and bought another one. No problems with that either. However, I didn't want to be using bought-in stuff. I wanted to design something of my own. I have a lot of old projects that could be modified and a lot of chips that's come off them. So I thought I'd have a go at building my own controller. And this is what I came up with. The device is basically a very old chip, a 741 LM, an LM741, which is an operational amplifier, but can be used as a comparator. So it's got 2 inputs that can be compared against each other. And basically what happens is, if pin 3, which is usually given a plus sign, which confuses it with 7 for me, but anyway, the non-inverting input, it's called, is higher than the inverting input, then the output goes high. And if pin 3 goes lower than pin 2, then the output goes low. So that then forms what we call a comparator. So if we start over here, we've got 12 volts coming in, put a little switch on so I can switch it off, then through a diode. So if I connect it the wrong way round, the diode should stop it being blown up or ceasing to work. It won't blow up, it'll just cease to work. Perhaps, as one guy says, black smoke. And then I've got my indicator here to show that it's got power. So often I have these things and leave the switch off, think it isn't working, and that's because I haven't got it switched on. Then we have a potential divider here with the thermistor at the bottom, which I think is something like 20 kilo ohms, and a 6K8 resistor up at the top to sort of balance it to get the right sort of voltage out. So I've got something to compare it against. I've just put a potential divider onto pin 3. Pin 7 and 4, 7's positive, 4 0 volts, and pins 1, 5 and 8 aren't actually used in this application. The output then from pin 6 goes into a 2K2 resistor, which feeds into the base of the BC549, so that this will actually switch off as this output doesn't actually get down to the 0 volt rail. We stuck a 1K resistor in here to pull it down, so this will actually switch off. The motor then connects from positive to the collector of the transistor, and I've also put a little LED across the output so that I can see when it should be on and off. So yeah, that's my circuit. I did a little what for it, circuit board. So here I have my circuit board. I actually filled in the areas with copper so that it wasn't using as much of my ferric chloride up. So that was the circuit board, and then this was the layout for the circuit board. Input here, switch, diode to prevent it, comes down after the diode, the positive comes into the variable resistor, which also connects to 0 volts, and then goes underneath the chip to pin 3. Pin 2 is fed from this resistor, which goes up to the top, forming a potential divider with the thermistor over here. Pin 7 is positive, pin 4 0 volts, and then out from there we have R5, which is the one that feeds the base of the transistor. The base is also pulled low by this resistor here. Here I've got the resistor for the LED on the output, and this is my output. So essentially that is my circuit. So if we come in here, hopefully we can see it built. Put it in a little box for safety's sake, and I've also put a couple of magnets onto the other side. These are what we call countersunk screws. Only had one posi and one slotted screw, so I've used one of each. Bad practice really, but it works. The thermistor itself is just bent over the side, so that when this is on the radiator, the thermistor is close to the radiator. Variable resistor didn't have a knob for that, so I put a lump of wood on, and there's the 741 chip, output over here, and transistor there. I've just glued it in. I was tempted to put a couple of solder tag washers on and then bolt it down with those, but if these touched metal, then that will be on positive, that will be on negative, and I'd have a short circuit. So does it work? Well, let's try it. Let's see if we can find, oh, we have a power on it. So if we switch it on, our LED comes on, nothing happens. So I can vary it with my variable resistor so that the LED is just on, turn it so it's just off, touch the thermistor hopefully, and there we can see that it's come on. Don't know if you can see as well, the fans have come on, and after a little while the thermistor cools down and everything goes off. It actually works that if I heat it up to a reasonable amount and then stick it above a fan, it cools it quicker. And this way it proves to me that this is actually working, because when it's on the radiator, the fans cool the radiator down, so the thermistor switches off, but the radiator's still got warmth in it, therefore it heats up again and the thermistor comes on again. A process called hunting. It does this about 4 or 5 times before the radiator's cool enough not to switch the thermistor on. Could have got over that by using a process called feedback, and this would mean that I would take the output back into the input, and that way I would get a delay between it coming on and going off, a temperature differential as it were, and this is called hysteresis, but it works okay for me. Many people say that these systems don't work, but as I say, it seems to work for what I want it to do, getting the room up to 21 degrees when it wouldn't get there in the past. Obviously not very objective. I'd need to do a lot of tests to prove it was actually working, but it seems to work for me. Doesn't go immediately, takes hours to get the room up to temperature, but it gets there eventually, and then the thermostatic valve on the radiator switches off. This system then, the radiator cools down, this switches off, and it stays at that temperature until the thermostatic valve comes back on again, when this system works again. So yeah, quite chuffed with that. Happy with what I managed to do. Seems to work for me. May not be what everybody wants, but I like it. So it's bye now. Bye.